So welcome back. In today's lecture, we are going to see the problem, and again I have to extremize some functional, and at this moment what basically we are assuming that final time is specified. Okay, so time is known to me, but XTF is free. Okay, so try to see the possible or admissible trajectory. You can see that for simplicity what I am assuming that I have time, and we know that solution of extremization of some functional is function. So I am assuming that xt that is going to extremize that particular functional. Okay, so if you see the admissible trajectory, so what basically we are assuming, I assume that I know the t0. Okay, so this time is known to me. After that, what I am assuming that corresponding to this time, whatever initial condition xt0 is also known to me. Okay, and due to that reason, my trajectory is going to start from this particular point. Okay, after that, what basically we are assuming another thing, that you can see here that t0 and tf, this is tf, so tf is known to me but xtf is not known to me. It means that xtf, if you see xtf, then there are infinite many possibility for the xtf if xtf is not specified. So this is basically free. It means that extremal of some functional, whatever functional I have defined, that t0 to tf, and after that I have defined l x x dot t is silent here and t, and after that we are telling that okay, I have something like here I have t, and after that I have to extremize this function. Suppose this is dt. So if you are going to extremize this gx, at that time you can see here that this particular functional, what I am assuming that t0 is known to me, tf is known to me, xt0 is known to me, but xtf is free. So I have infinite many possibility. So one of the curve might be looks like something, I don't know what kind of curve that comes into picture. Okay, if final thing is fixed, xtf is fixed. Okay, then what happens, variation, here you try to see the variation with respect to time. So variation with respect to time t0 is 0 because t0 I know, tf I exactly know, so variation with respect to time is 0. xt0 initial variation with respect to this state is 0 because xt0 is exactly known. What one can comment about the xtf is variation of xtf is 0. What are you thinking? Anyone could you please comment about this?
Not zero.
No, not 0, because it might possible that I have some curve here and I can tell that okay, I have to look all possible curve in this neighborhood of that, and out of that I have to select the extremum curve, and due to that reason now I have to make sure that variation of xf, okay, that is arbitrary. So only one possibility is that whatever coefficient that is associated with this delta xf, that should be 0. Then only I can tell that whatever the variation of this functional that equal to 0. Okay, so let us come to the problem statement and after that I will discuss. So what is our problem statement? Find a necessary condition of a function to be extremal for the functional, and I have again defined the same functional, and here what I am assuming, t0 is known to me, xt0 is known to me, and tf are specified, and xtf is free. Okay, I have already plotted and discussed the admissible curve. Now whenever I have to solve some kind of extremization problem, first step I have to calculate the variation. Okay, and in the previous class, using numerical example also we have done that how to calculate the variation. Okay, or during proof also we have seen. Okay, so complete derivation of this particular variation is actually online available, so please check the lecture. Okay, for the complete derivation, so I have just written here the final variation. Okay, and in order to make sure that there exists a extrema, I have to keep this variation equal to 0. Okay, in this variation, what I am assuming that nothing is fixed. Okay, I am assuming that except or final state is also not fixed. Okay, or final time is also not fixed. Okay, and due to that reason, some term which has variation with respect to final condition, that also comes into picture. With respect to variation in TF, that also comes into picture. Okay, and obviously variation with respect to delta x is always there. In previous situation also we have, and in order to make sure 0, because here what is the basic idea, that delta f, delta tf and delta x, everything are independent. Okay, and in order to make sure that is linearly independent, means independently I can vary delta xt, delta tf and delta xf. Okay, so here we are considering some kind of situation where I am assuming that final time and final state is also not known. Okay, it means that I know some kind of, it might possible that final time or final state is going to lie in some surface. I don't know about that. Okay, and due to that reason, first I have actually given the generalized derivation, and using this derivation now you can see that you are able to figure out all different kind of situation. Okay, if suppose that initial time and final everything is fixed. Okay, if suppose some kind of situation, same kind of plane I have, and suppose these two things are fixed, t0 is fixed here, xt0 I know, tf I know, and xtf is known to me. If everything is not known to me, then variation with respect to t0, xt0, tf, xtf all equal to 0. Okay, now only one variation is allowed, that is variation with respect to x. Okay, and due to that reason, now you can see that since delta x, if both point are fixed, then this equal to automatically equal to 0, so there is no need to worry about this. If both end point is fixed, again delta tf is also 0, variation with respect to delta tf is also 0. Due to that reason, again that is multiplied by 0, so there is no need to worry. Just we have to worry that delta xt, that is not fixed, I don't know the extremal curve, and due to that reason arbitrary one can vary this. Due to that reason I have to make sure that this equal to 0, and this is nothing but, if you see carefully, then that is Lagrangian equation. Okay, now here situation is like this, that I know that variation with respect to initial time and initial, you can interpret that as a initial state, you can assume. Okay, here tf is known, so variation with respect to t0 and tf, that is 0, but variation with respect to delta xf, now I cannot assume that equal to 0. Okay, so this is now arbitrary. Okay, obviously this dtf is 0, so due to that reason this term will not comes into picture. Okay, now I have two terms that comes into picture, one variation with respect to x, one variation with respect to xf. So now could you please guess what is the condition such that extremal comes into picture? Anyone? Subham, could you please guess? Subham, are you here?
Yes, sir.
Could you please guess that what is condition for extremal? Yeah. First, what you think like this, variation equal to 0. Now in order to maintain variation, I have, you can see here delta xf term, delta tf term, delta xt term. Okay. So we have already removed this term because I know that final time is known to me. So variation in final time equal to 0. But except is not known to me. So due to that reason, this is arbitrary. But now I have to make sure that addition of this term and plus this term equal to 0. And we also know that delta xf and delta xt both are linearly independent. So what is condition such that I can able to make sure that combination of these term equal to 0. Have you able to understand the question, Subham?
Yes, yes, sir.
Just you can guess, even if wrong guess is okay. Okay, if two quantity is linearly independent, then what kind of things I have to force? In previous
So
class, I have
we
told you.
can
Okay, just you can give me answer of very simple question. Suppose x vector and y vector you can take and both are linearly independent. Then what is
yes.
condition?
So they are both are orthogonal to each other.
Previous class also I have told you that orthogonality is okay, but you have to come from the definition point of view. What kind of definition I have told you in the previous
So
class?
if they are both independently, then we can uh, equate equals to zero both independently.
So
Uh,
vector is non-zero. How one can equate vector equal to zero? Babita, could you please comment?
Sir, coefficient of that terms is equal to
Yeah,
0.
coefficient. Subham, try to
yes, sir. Yes.
understand that coefficient. You have to just check the definition of linear dependence and linear independence. Okay. And due to
Yes,
that
sir.
reason, linear algebra people are teaching linear dependence and linear independence. And same kind of things I have discussed in previous class. Why you are not giving care? I don't know. Alpha v1 plus beta v2. So alpha and beta is some kind of a scalar you can assume. If v1 and v2 is linearly independent, it means that alpha v1 plus beta v2 equal to 0. That implies alpha equal to beta equal to 0. That is meaning of linearly independent. If alpha and beta, at least one of them is non-zero. Okay, because I cannot tell that v1 and v2 is 0 because v1 and v2 is given to me. Due to that reason, only one condition alpha and beta both equal to 0. So similarly, here you can see that delta x1 and delta xf and delta xt I can vary arbitrary. Okay, so if I have only one state, then that is a scalar quantity. If vector, then vector kind of quantity. That doesn't matter for us. So just we have to equate coefficient equal to 0. Okay, and if you do that, then this is nothing but Lagrange equation, Euler-Lagrange equation, and apart from that, some extra equation that comes into picture, that is dou L by dou x dot and x star tf and x dot star tf. You can see here that tf condition you have to substitute. Okay, and that should be 0. Okay, anyone has confusion, then please let me know. Iram?
No, sir.
Okay, now you can give answer to one question. Okay, I will reverse the situation. Okay, then what kind of modification that comes into picture? Suppose now that here xt0, t0 I know, but I don't know xt0, and tf and xtf both are known to me. Okay, so what I am telling that, suppose you can take one situation that I have some kind of static enemy. Okay, I want to, and I have several base station. Okay, it means that xt0 has several value. Now what I am trying to do, I am trying to fire some kind of missile, okay, from this point to enemy. Enemy is static, means xtf and xtf both are known to me. Okay, but here t0 initial time I know when I have to fire and at what time that is going to destroy the target. Okay, so now if someone asks you that what is possible path, okay, now here in this particular variation, what do you think, what kind of things basically comes into, what kind of change that it comes into picture?
Sir, in that case, variation with respect to final time and final state will be 0.
Okay, obviously that is 0. Okay.
And variation with respect to initial time is 0, but with respect to initial state is non-zero.
Yeah, initial time is 0, and so here in this expression, what kind of modification that comes into picture?
In this case, delta xf is 0. So
No, except so here in place of xf, now I am going to replace x0. Okay, or
then
x
its
initial.
coefficient should be 0 for extremum, sir.
So in coefficient, what kind of modification that comes into picture? I want to know.
So that will be x star of t0,
Yeah, x star of t0, x star of t0 here, x dot star of t0. Okay, star is here. That is missed by me, and t0 is here. That much only difference that comes into picture. Okay, and several place this kind of problem. This is very realistic problem. Okay, several time what happens that I just know the time. Okay, several time it might possible. Okay, it might possible, suppose that some target is actually moving on a straight line. Okay, and I have to hit the target. Okay, so now I have to make sure, and suppose that target is moving with constant velocity or something like that. Okay, so that is going to lie in this path only. Okay, we can create the complicated situation using some example in the later class, but in today's lecture, what I am assuming that here something is moving linearly. It means that that is going to lie somewhere here. Okay, and I have to destroy it. Okay, so that kind of situation. So due to that reason, people are just solving one problem, that they are assuming T0 and TF, XT0 known, but TF is free. But when reverse situation comes into picture, then exactly in the same way I can able to solve the problem. Anyone has confusion that why we are equating this coefficient? So I think that these kind of things become clear to everyone. And whenever we are solving any extremal problem, so one thing that comes into picture, that is Lagrange, Euler-Lagrange equation. Okay, that will always appear because I have to find the trajectory, and variation with respect to trajectory. Okay, that is always arbitrary, that is never zero. Due to that reason, this coefficient should be 0. Okay, so Lagrange equation that always comes into picture. Okay, have you able to understand the proof or not? Idea of proof is like this: whenever you have some performance measure or some kind of functional, you can take the variation, and after that make sure that what kind of variation is 0. If that is 0, then that is not a problem. If that is non-zero, then coefficient associated with that should be 0. We know that extremization of any functional is some kind of function. Okay, and due to that reason, delta xt is never 0. Okay, that is non-zero. Due to that reason, coefficient equal to 0. So in that way, Euler-Lagrange equation comes into picture. Okay, now if you allow some kind of extra condition, some natural boundary condition that comes into picture. Okay, at that time delta xf is non-zero. Due to that reason, you have to equate that equal to 0. So based on this idea, now in today's lecture I am going to solve the problem. It might possibly in next lecture what I will do, I will now, suppose from here you can easily able to guess. Suppose that now t0 and xt0 is given, tf and xtf. Okay, among this now xtf is known, but suppose tf is not known. Okay, so could you please draw the trajectory? What kind of trajectory that comes into picture? Could you please think? Suppose I will start from here. So I know the t0, I know the corresponding xt0. Okay, this point I have written wrongly. This should be xt0 because here I am writing so xt0. Okay, so this point is xt0. So these are known to me. Now suppose that I know exactly the xtf. It means that I know some quantity like this xtf. Okay, so what is possible trajectory? What is admissible trajectory if I want to extremize? Are you able to picture out that trajectory maybe like looks like this? Because TF is now free. Okay, so thing is that now I know the location of some point. Okay, but I have flexibility. Okay, so I know the location, but sometime I can hit the target quickly. Sometime I can wait for several hours also. Okay, now I have to find the extremal path. In that particular way, could you please suggest what kind of modification comes into picture? Priyanka, could you please guess? So variation remains the same, whatever variation I have calculated. Okay, so what kind of modification that comes into picture from the previous case? You can see that just I flip two things, two situation. Initially, TF is known to me, XTF is free. Now I am assuming XTF is known to me, but TF is free. Priyanka, are you here?
Yes, sir.
Could you please suggest? First, could you please tell me that this quantity, what is happens to this quantity, first quantity? This is zero or non-zero? Just you can comment about delta xf. What do you think? Don't worry, even if you can take you will tell wrong answer, that is also okay for me. In this way I am able to guess that you are understanding the lecture or not. Okay, Shikhar Gupta, could you
Yes,
please
sir.
guess
Yes, sir.
delta xf is zero or non-zero?
Sir, delta XF will be.
I have flipped this situation. What I am telling that initial moment time and xt0 both are exactly known to me. Final final time, okay, that is now unknown to me, but I know the final state xtf. Okay, so at that moment delta xf is zero or non-zero.
Sir, zero.
Why?
Because XF is fixed.
Yeah, fixed.
XF
Due to
is,
that region variation, if something is fixed, it means that I know that thing exactly. So no variation is allowed. Priyanka, are you able to understand this point?
Yes, sir.
So why you are not able to answer? Okay, so it means that delta xf is zero, then there is no need to worry now. But Priyanka, now could you please answer what about delta tf? That is zero or non-zero? Priyanka,
जी sir.
what do you think? That is zero or non-zero?
Sir, non-zero.
Why?
Sir, because it is fixed.
If something is fixed, then variation is zero or non-zero.
Sir, would be zero.
So initially you tell that this is non-zero, and now you are telling that that is zero. So what is your final answer?
Sir, if it is fixed, then the answer would be zero. Value would be
So
zero.
in this situation, on means it is fixed or not fixed.
So it is fixed.
I am asking this question. I am not asking this question. Now I am asking this question now. So what do you think? Here TF is fixed. Here XTF is fixed. TF can vary, and due to that reason, delta TF is non-zero.
Okay.
Okay. Now, if delta TF is non-zero and I can vary delta TF arbitrary, then how to give guarantee? And obviously delta X. Why delta X T is non-zero? Could you please tell? Could you please explain?
Sir, delta?
Delta X XT. why delta xt is non-zero? Vinay, could you please explain why delta xt is non-zero?
Because it is not fixed, sir. It is varying actually
Yeah,
with respect
because
to
we
the.
are trying to find the functional. I don't know the functional. If I have told you that if I know something, then variation in that quantity equal to zero. If I don't know, it means that that is arbitrary, and due to that reason now delta tf is arbitrary vector, delta xt is arbitrary vector. And what situation? That situation is same like independent vector situation, that this quantity is arbitrary, and multiplication with that quantity I have to select such that this equal to 0. So only one situation, if v1 and v2 is linearly independent, then I have only one solution, that I have to equate equal to 0. Due to that reason, in today's lecture I am going to solve only problem when I am assuming that tf is fixed. But next lecture, when I will solve when tf is not fixed, at that time my situation become different. This quantity, there is no need to worry about this quantity, but I have to make sure that this equation, okay, this differential equation should be satisfied. Okay, anyone has confusion on this point, then please let me know. Anchal?
Yes, sir. No confusion.
No
Sir,
confusion.
sir,
Okay.
sir,
हाँ
one question I have.
हाँ, please go ahead.
Sir, if T1 will be fixed and TF, all of four quantity are fixed,
Okay.
then XTF, so no, XTF is variant, XTS variant, not variance.
So try to
If
understand
four,
the situation. If
yes,
all quantity is fixed, it means that I
mm,
have situation like this. I know this point, I know this point, I know this point, I know this point. Okay. So this,
yes, sir.
now you can see that extremal of this, you have to you have to check various trajectory. So trajectory may be like this, maybe like this, maybe like this. Okay. And due to that reason, if this trajectory is x star, okay, so you have to check near neighborhood of that trajectory, means x star plus delta x. Okay, and due to that reason delta x variation with respect to trajectory, that is always arbitrary. Okay, how to select
Okay,
one, how to select extremal one? You have to vary the trajectory and test that that trajectory is extremal or not, and due to that reason delta x is non-zero.
okay, sir.
Any confusion? And this kind of situation will appear in each and every case, because even if this point is known to me and this point some quantity is unknown, still this trajectory is unknown, and due to that reason variation with respect to the optimal trajectory, that is always non-zero, that always arbitrary. And due to that reason I am telling that Euler-Lagrange equation, because this whole bracketed quantity is nothing but Euler-Lagrange equation, that should be always satisfied, means that equal to 0, then only I can tell that arbitrarily I can vary delta x and other quantity. Siv, is it become
Yes,
clear to you? Okay.
yes, yes, sir.
So idea is very simple. If you understood that how to calculate variation, what is meaning of linearly independent vector, then situation is pretty easy. After that you have to just solve the differential equation. Okay, now question is that how bravely you can solve the differential equation, and all differential equation you have already solved during your either bachelor first year or second year. Okay, now let us come to the question. Here you can see that I have this kind of functional, and after that here x0 equal to 1, that is given, and x1 free, that is given. So now could you please comment that what quantity is given to me and what quantity is not given to me, and what kind of variation that comes into picture? Priyanka, could you please tell me by seeing this example? Suppose this kind of question is provided to you. Okay, so what kind of interpretation I can give?
Sir, the initial value.
Okay, initial value x0, that is known
Yes.
to me. Okay, or
So the value at 1 is free, means
what does it mean? This is known or unknown? Something is free means known or unknown. Free means I don't know in advance. Okay. So x1 is unknown. What one can comment about T0 and TF? That is known or unknown? Priyanka? Could you please quickly answer it? Okay, how to identify T0 and TF? Priyanka, probably you are not following the lectures. Okay. Shikhar,
Yes, sir.
okay.
Yes, sir.
So Shikhar, could you please tell me that what is T0 or what is situation of T0 and TF?
So T0 is 0 and TF is 1. So
Yeah. So
both are
is it
fixed.
fixed or varying?
So both are fixed.
Yeah, both are fixed. Okay. So here, could you please comment about delta XF, delta TF, and delta X? Which one is zero and which one is non-zero?
So delta XF will be non non-zero.
Yeah,
And
perfect.
all the remaining will be 0, I think.
Yeah. You are exactly you are exactly right. Now, what I am going to do? Now I have to solve this problem. So I have told you that during solution of this problem, Euler-Lagrange equation is comes into picture. Apart from that, since delta this term first term here delta xf that is arbitrary, due to that reason I have to solve this equation d dou l by dou x dot that equal to 0. Okay, and now let us try to see the solution for the first problem. Okay, so here you can see that here lx, whatever inside the definite integral that I have defined as a L, that is given like this, and after that I have to solve. Whenever I am putting a star, it means that I am talking about optimal extremal trajectory. Okay, so dou L by dou x dot, it is not proper way to write like this, but here I have to unnecessarily write the argument. Due to that reason I have written in this notion. Otherwise, perfect notion is like this: dou L by dou x, and after that x star, x dot star, and after that t. Okay, like this we have to write. So I hope that you can interpret like that only. Okay. Now, if you solve it, you can see that I have to take partial derivative with respect to x. Due to that reason, 2x star comes into picture, and minus 2x, because I have to take partial derivative with respect to x dot, so 2x dot comes into picture, and after that again time derivative, and due to that reason this differential equation, second order differential equation, that comes into picture. Okay, Shiv, could you please tell me that this is linear differential equation or non-linear differential equation?
Linear difference equation.
Okay, why?
So because of output 0 which is equal to 0, here is something is presented, then it's not linear.
So I am not talking about homogeneous and non-homogeneous. I am talking about linear and non-linear. Here, answer
So
is
any, so xt is not in other
yeah.
type like e to power x
Yeah,
something
yeah,
or
yeah.
sin x something, then it is
That answer
linear.
you have to give. Okay. Now, if you solve it, you can see that this is the solution. And after that natural boundary condition means I know that delta x xf that is non-zero, and due to that reason coefficient associated with delta x0 that should be 0, and from that I can get this kind of equation. So several times I am telling that whenever I am discussing this kind of question, now you can take your copy and pen and try to solve it by yourself. Then your understanding become fully clear. Okay. Now what I know that x dot star 1 that equal to 0. Okay, because I know the x dot star equal to 1 equal to 0. From here I know. Okay, I don't know in advance. From here I have I can conclude. Okay, now x star I know, this trajectory I know, so I can able to differentiate this trajectory, and after that I am going to substitute the initial and final value. Okay, so if you substitute that, in that way I can able to calculate the C1 and C2, and finally you have to just keep the C1 and C2 inside the expression, and that is the solution of the extremal trajectory. Anyone has confusion? Then please let me know. Similarly, now let us come to the second question. Okay, second question is like this. Here again question is exactly the same, but I have just changed the performance measure. Okay, and after that you can see that x0 is half and x1 is free. Again similar kind of situation. It means that term associated with delta xf, that is dou L by dou x dot at the final time, final state, everything that should be equal to 0. Okay, so if you proceed in similar way, you can see that now what we found, that again you have to solve the Euler-Lagrange equation. I have already told you that why always I have to do that. Okay, and apart from that I have to also solve the some equation for the boundary condition. Okay, and boundary condition equation dou L by dou x, and please be careful that I have to solve this equation at x star 1 and x dot star 1, and both are not known to me, both are unknown to me. I don't know what is the final state, and due to that reason I don't know what is final velocity. Okay, and due to that reason again some differential equation comes into picture. Okay, and most of time you can see that here second order differential equation comes whenever we have one variable, one more equation that comes into picture here. Okay, but that is fully depending on the L structure of L here, that what is order of that equation. Okay, and after that now if I substitute everything, then I can able to get or obtain the optimal or extremal trajectory. Okay, now let us come to the again third question. So third question is little bit now little bit complicated, and I will take actually now hint from you to solve this question. Here you can see that whatever performance measure I have defined, that is x dot square t, x dot square t, 2x1 x2, like this. Okay, something is missing here. I hope that dt is missing. I will check it. Okay, dt term is here, and after that here you can see that I have two state here, x1 and x2. Now initial condition of both state and their starting moment is provided to us, both are 0, but one state x2 is known to me, another is unknown. Okay, now could you please tell me that first, could you please guess that how many Lagrangian equation comes into picture? Anchal, could you please guess how many Lagrangian equation comes into picture, and about which variable? Euler-Lagrange equation I am asking.
Yes, sir. We need two equations.
Yeah, two equations, one in form of x1, another in form of x2. Okay, and each Euler-Lagrange equation has the order, and what is order of that? Order is basically 2, and due to that reason I have 2 plus 2 means 4 differential equation. Okay, so fourth order, four first order differential equation you can tell. Okay, now could you please guess that how many differential equation that will appear due to boundary condition, 1 or 2? Could you guess quickly? Litika, could you please guess? Litika, are you here? How many equation? So Lagrangian, two set of Lagrangian equation comes into picture by seeing the boundary condition. Okay, could you please guess that how many equation that comes into picture?
2, sir.
Dhananjay, what do you think?
Sir, I think one.
One. Yeah.
Because initial
Yeah.
x1 in
Yeah,
we
only
don't know the
x1 is
final
free.
position.
Okay.
Yes, sir.
Litika, are you able to understand that point? Here you
Yes,
can
sir.
see that x1 pi by 2 that is free and x2 pi by 2 is fixed. Due to that reason, only one boundary condition in terms of x1, okay, dou L by dou x1 dot, that kind of situation that comes into picture. Okay, anyone has confusion on this point? Then please let me know. And due to that reason, if you see the solution now, so similar kind of things that is going to reflect inside the solution. Okay, I'm going to open the solution. So here you can see that the problem is little bit actually a little bit means numerically involved. Just numerically involved means you have to do lot of calculation. Okay, so now again we have proceed like this. I have two set of Lagrange equation. Okay, and I have obviously I have to solve that Lagrange equation. Okay, and after that corresponding to each Lagrange equation, now what happens that I am going to get some kind of differential equation, one differential equation and second differential equation, and again and same kind of situation that appear in previous class. Then we have taken the two time derivative, and after that fourth order equation we are getting, and after that we are getting the curve. Similar kind of things up to here, that is okay. And after that now we are specifying the boundary condition. You can see that I have specified the, I know that x1 star 0 is 0, x2 star 0 is 0, and based on that I can able to establish relation between c1, c2 and c3. So I actually get this kind of relationship, and after that what we have to do now, I have to generate some kind of boundary condition. And I have told you that since x1 is only free, due to that reason one expression that comes into picture, that is dou L by dou x1 dot. Okay, and here everywhere I have to update x star pi by 2. Could you please guess here why I haven't written x1 and x1 and x1, not x1 and x1 here? I have, why I have written generalized? Anyone, could you please guess? Or I have done something wrong? What do you think, Bhavita?
I think, sir, we have done the differentiation with respect to x1. So
Yeah, that is okay. But what about argument? In argument, I have to write x1, or free argument x1, x2, everything I have to write.
but sir, differentiation is with respect to x1, then we get the output terms in the x1.
Only in x1. Suppose
Yes,
I have some term like x1, x2 multiplied by x1 dot.
x1, x2 multiplied.
Suppose I have this kind of term in some situation, then what happens? If you take partial derivative with respect to x1, then x2 will also appear, na?
Yes, sir.
And due to that reason I don't, but I know x2, what is, I know the final value of x2, and due to that reason you can see here that here I am not specifying x1, and here this may be x1 and x2 both. Okay, it means
Okay.
that x star tf, meaning of x star tf is x1 x2 both. Anyone has confusion on this point? Okay, so please try to understand. Sometime this will create the confusion, and after that if you solve it, then this kind of actually function that comes into picture, that going to extremize the this functional. Okay, so now it is time to conclude the today's lecture. So in today's lecture what we have done, we have solved some kind of extremization problem of some functional, and what we have assumed that initial time and initial state, final time is known to me, but final state is not known to me. Okay, and we have discussed the reverse situation also. Suppose that initial time is known to me, but if initial state is not known to me, final both are known, then how to solve this problem? Okay, and all different combination of this form are recorded in one lecture. Okay, so if you have time, then please go through that. Okay, so there also I have solved one problem, but here I have solved several problem, 2 and 3 problem. Okay, so I hope that everything become now clear to you. Please again go through the lecture, then you are able to understand clearly. Okay, and in next class I will teach some part of theory, and after that again I will come up with some numerical. Okay, in this course I am going to fill the gap, whatever gap that is on online lecture I am trying to fill. Okay, so if you have any question, then please let me know, otherwise I am going to close the today's lecture. Anyone? Okay, I am going to end the